diagrammatic representation of data. We have studied about various diagrams which could represent the data. Why one should go for diagram? When you have certain data present in the form of this tables, so why should you keep on drawing the diagrams, and why not just see it from the tables itself? It's because the merits for drawing the diagrams is that most of the people are attracted by diagrams. Then technical knowledge is not so necessary when you see the diagram. The time and effort to visualize the data, visualizing certain data from the figures and graphs, that is quite easy. You can see the graph, okay, and you will tell, okay, these many people are having do have characteristics, this one, and so on, things like that. But from seeing certain table, you cannot immediately say, okay, what is the characteristic that these people follow. So you cannot directly say that. The diagrams show the data in proper perspective. They leave a lasting impression on the viewer. Language is not a barrier because that is a visual representation and it is a widely used tool. In fact, many people in research use these kind of things because they prefer figures over tables. So that is one advantage of using this data. But what is the limitation? There are also certain limitations that are involved. So they are that diagrams, they are the approximations, they are not exactly the same thing. If you have certain amount of data, for example, if you have certain ranges, say you wanted to represent 0 to 10, so in that case you can draw it using graph. But now I say, okay, I want my graph to be 0.5 to 10.1. So in that case, it is difficult to make the distinction in this particular case. So that is why this is not so good idea to represent the data through diagrams. So they are approximations. The minute differences in values cannot be represented in diagrams. Large differences in values spoil the look of diagram. For example, you have one value whose value is say 0.005, and one value you have say 10,000. So there's a huge amount of data, so you won't be able to see one point would somewhere here or one point would be somewhere here. So it would be difficult to visualize such kind of points, one here and one here. So for these I have took these small numbers. There could be large numbers as well. So minute differences in values cannot be represented properly in diagrams. Moreover, large differences in values, they spoil the look of the diagram. Most of the diagrams are drawn by experts only. So for example, this pie chart, you know how to draw the pie chart, so it is difficult for the person to understand as well. And for the layman, for the normal person, it portrays portraying different scales is not so easy. So we have studied about this bar diagram, we have studied about pie charts and the histograms. So let us have a quick look at these one. Simple bar graph is something which have simple bars in it, right? For example, if you wanted to represent the area of different crops in a state, or food grains production of different years, the yield performance of different varieties of crop, the effect of different treatments, etc. So these could easily be represented by bar graph. For example, we have this example, the cropping pattern in Tamil Nadu in the year 1974 to 75 is given as follows. So these are these crops, these 5 crops are given to us. 1. Cereals, oil seeds, pulses, cotton and others. And for these 5 crops we have area in 1000 hectare. So this is given to us. So we can use the simple bar graph to represent this. Each bar represent each crop. So cereal, oilseed, pulses, cotton and others. Moreover, we have the area in hectares represented here on the vertical axis. So from by looking at this graph, one can very easily say that okay, cereal has the maximum area in hectares, followed by this oil seeds and some other crops in the year 1974 to 75 in Tamil Nadu. So this is very clear information that is depicted from this graph. Moreover, instead of single bar graph, we can also have multiple bar graphs. So how do we have how do we draw multiple bar diagrams on a single one? For example, you have three characteristics. In this particular year, we have food grains in tons, vegetable in tons and others in tons, right? So we have three characteristics in this period from 2000 to 2004. So how can we draw this in the graph? So what we have done, we have listed this according to years. So for the year 1974, we had three crops. One column was for sale, one for gross profit, one for net profit. So according to them, these in the year 1974, we have marked these three bars. One is this one is this one, and one is this one. So similarly for other years also we have marked these years and bar graphs. So we can also draw multiple bar diagram for various characteristics given in the data. Component bar graph is, instead of representing these bars side by side, what you can do, you can put them on top of each other. So from here it is not so clear that okay, what characteristic is larger. For example, you cannot tell about gross profit. What is the largest gross profit in all these years? So your answer might be this one or this one, but you cannot make a clear distinction that which one is greater in this. Whereas in this one it was clear, the maximum was this particular characteristic. So what you can do instead is, instead of making this component bar diagram, we can draw the percentage bar diagram. How we can do that? We can do that by using this formula that we can divide this actual value by the total actual value into 100. So in this case, for example, the percentages are calculated for each one. So now you can make a clear distinction. So we will go up to 100 for each of these graphs. Each of this bar, the total value is 100. And the proportion of these three components, net profit, gross profit and sales, has been listed. So now it is easy to make conclusions more easily in this kind of graph. So next is the pie chart and pie diagram. What is this? This is a circular pie shaped graph, and it could also be used in place of bar diagrams. It consists of more than one circles which are divided into a number of sectors. So how can you know what size one sector have? So we can calculate the angle of that particular sector by dividing the actual value of the data by the total value and multiply by 360 degree. So we multiply by 360 degree. So why we do that? Because the total angle we know that is this total angle, that is 360 degrees. So if we multiply this proportion by 360 degrees, so we are dividing this whole circle, into different sectors or pies, different sections. For example, we have the given cultivable land area in 4 southern states of India. So we have to construct a pie diagram for the following data. So we have 4 states: Andhra Pradesh, Karnataka, Kerala and Tamil Nadu. and the cultivable area in hectares is this much. Total is this much. So firstly we'll find the corresponding angles. So how we can find the corresponding angles? It is calculated for Andhra Pradesh, it would be 663 divided by 1957 into 360 degree. So when you do that, it comes out to be this one. You can check it and verify it by yourself. How do we obtain this kind of graph? And next we have the histograms. So what is histogram? Histogram is used whenever we have continuous data. So whenever we have class intervals which are to be represented. So in histogram we represent this class intervals in x-axis, and the basis of the bars, they are the respective class intervals, and the frequencies, that is represented by y-axis. The heights of bars are equal in the corresponding frequencies, and moreover there is no gap in this kind of bars. So there is no gap within the bars because the classes, they are continuous. One class ends and the other class starts. For example, we have this data, seed yield in grams is given in the class interval range. So that means 2.5 grams to 3.5 grams. We have number of plants as 4. In this range 9.5 to 10.5 we have number of plants as 5, and so on. So we wanted to represent this histogram data through histogram. So firstly what we do, we just create the class intervals. So here they have represented it through various colors. For example, this violet color for the class 2.5 to 3.5. So what you can do, you can write the class intervals here. So 2.5 to 3.5, 2.5 to 3.5. So this you could represent here in the x-axis only. So this is the first graph. Then for second one you can write 3.5 to 4.5 and so on. So here these bars, they do not have any gap, they are continuous, they are joined together without any bars, and here is the number of plants mentioned on the y-axis. So this is the histogram. Next is the frequency polygon. What is frequency polygon? For frequency polygon, what we do, we calculate the midpoints of these class intervals. So once you have the midpoints, you represent that point in the x-axis and this point in the y-axis. So you have some point, for example, the midpoint of 2.5 and 3.5, it is 2. So the midpoint is 2. So what do you do for this point 2 here? So this is the point 2. You just this is the point 4 here. So you just point a plot over here. So this is the point corresponding to first class and first frequency. So similarly you draw these for the next class. For this class the midpoint would be 3 and its frequency here is given to be 6. So we, for the 6 and 4, we just draw this point, then this point, then this point, this point, this point, this point, and this, and the last point. So we can join all these points, and then that is our frequency curve. So this is as simple as that. So you can draw this curvy line. So this will give you your frequency curve. So I hope this is clear to you. If you have any doubts, you can ask me.